Just want to review the first example that we did when we were talking about motional EMF. This was our contrived example with the conductor that's moving through a magnetic field, our little bar. When we move this bar through this magnetic field, the charges within experience a magnetic force. That's one of three different forces we have to consider here, and that's this force right here, okay? What we see is that that induces an EMF and we have the positive charge flowing clockwise. In order to keep that bar moving, there needs to be an applied force. The reason for this, to keep it moving at a constant velocity, is that there's a resistive force. Once that EMF is induced and we have a completed circuit, there's going to be a current moving through this bar. That current is going to create a magnetic force acting on this conductor. If we use our right-hand rule, we can see that with the current moving up like this, all right, the clockwise current, is going to cause, if we put our thumb in that direction, put our fingers into the board, our palm points to the right. So we see that with the current moving in this direction, that actually exerts a force on our conductor. Because of that, we need to apply a force in the opposite direction to keep that conductor moving at constant speed in order for that EMF to exist. How do we figure out what that applied force needs to be? Well, to do that, in the very first example, we calculate the EMF. If you go to the front page of your packet, it's 6.4 volts. The current, because of the 96 ohms resistance, is calculated to be 0.067 amps. So the situation here requires us to actually calculate the power. The reason for this, and first of all, let's just quickly do this. It's just going to be current times the EMF. When we do that, we get 0.43 watts. Okay, this is from our section on circuits, so hopefully, if you don't remember that, just go back and review it quickly in Chapter 5. But what happens here, okay, is that if we're applying a force and moving at constant velocity, that we're actually generating or using a certain amount of power to do that. And in kinematics, we derive that the equation to apply a force at constant velocity, all right, would generate this much power. This is the equation that we had, all right? And so if we want to solve for force, we're just going to take power and divide it by the speed at which we're moving. And when we figure that out, we end up seeing that we need a force of 86 thousandths of a Newton. That's going to oppose the force from the magnetic field, that resistive force. What this is saying also is the power dissipated by the circuit is going to be equal to the power we're putting in to move this bar. Okay?